Okay, let's look at some of the different questions that you could be asked from the chapter 4 stuff. So it's all about graphs, transformations, and different types of graphs. So this is cubic equations. So sketching a cubic, these have already been factorized, so you don't have to worry about that. You just have to put the points on, so x is -1 here. Notice that that one is squared, and so it's going to, it's not going to go through the graph at -1, it's going to bounce off the graph at -1 because that's a repeated root, and then the other one is +1. Now, if it's a cubic, it has that general kind of up, down, up shape. If we want to know where it crosses the y-axis, then do 1 times 1 times -1. So -1. And that should give us everything we need to know, remembering that it bounces off at this point. You go up, bounces off, down, through at -1, and then like that. Now this wasn't very good, not normally quite so sharp, but it should be a smooth line through those points. Now it's going to deduct your marks for your line not being perfect, but it should go through all the right points on the graph. If I do this one as well, F, so this one was A. If I do F, then it's going to have a repeated root at x equals 1. So that means it's going to bounce off at 1. And then the other root is, when it says x there, that means it's going to go through 0. So, again, it's going to have that general up, down, up shape, and it's bouncing off at 1. And you're going to go through, obviously, at here, so -1 times -1 times 0 would give me no constant. So, up, down, bounce off, and then up. That was better. Not brilliant, but it's got that general cubic shape. Be careful for some things like this. That tells you that the graph is going to have a negative leading coefficient, so it's going to have this shape, like down, up, down, because 2 minus x is x minus 2 times by -1, which means that the whole thing is negative. So you could replace 2 minus x with minus x minus 2, and then you've got x plus 1 squared, so you can see it's going to be a negative graph. There's quite a lot of questions in this book, but a lot of them are just graph drawing, so it's a large book, but most of it's just sketching graphs. Actually, let's have a look at this question. This is kind of doing it backwards. So we've got a cubic. We can see by the graph that D is the y-intercept. That's going to be 2. You don't even have to do much maths, just a bit of understanding. And then here you've got -1, 2, and 3. So we know that our graph is going to have roots of -1, so x plus 1, 2, so x minus 2, and 3, x minus 3. But that, just because you've got x plus 1, x minus 1, x minus 2, sorry, x minus 2, x minus 3, doesn't mean that there's no constant term at the start. So you could have any number here and it's not going to affect the roots. You can see that when you try and transform a graph by timesing it by something, the roots don't change. So this could be something at the start, and in this case there is something at the start. It's not just a 1, because if I were to look at this, 1 times -2 times -3, that's 6. But we know it crosses at 2, which means that A is a third. You don't have to expand the whole thing to see that. So, what are we doing? Oh, no, I'd have to expand it anyway because that's the question. But we've got a third, x plus 1, x minus 2, x minus 3. And now it's just a little bit of practicing algebra, I suppose. So a third, x plus 1, and then multiply these two together. So -5x plus 6. And then expand again, third. And then we do x times all of these, so x cubed minus 5x squared plus 6x, and then plus 1 times all of these, x squared minus 5x plus 6, and then times everything by a third and combine together these. So let's do one of those at a time. X cubed, oops, minus 5 plus 1 is minus 4. 6 minus 5 is plus 1, and then plus 6, which becomes a third x cubed minus 4 thirds x squared plus 1 third x plus 2. Now, if you're not sure you've done any of your, where have I put my calculator? If you don't know if you've done your expansion correct, then what you could do is put in one of the values you know is a root, say put in 2, and see if the answer comes out to be 0. So I'm just going to quickly get my calculator. And then just substitute in x equals 2 and hope I haven't made any mistakes. So a third, 2 cubed, minus 4 thirds, 2 squared, plus a third, 2 plus 2. Fingers crossed, 0. So that's very likely to be correct. Moving on to these are quartics. So 1, 2, 3 and 4. That means that we've got some roots at minus 4, minus 3, minus 2, minus 1. And they're all positive, so we've got a W shape. So it's going to go down, up, down, up. Again, if we wanted to find out where it crossed this axis here, we would put in x equals 0. So that would be 1 times 2 times 3 times 4, which is 24. I hope. Other ones will be the same. Is there anything where it's negative? No. I will do C, actually, because it's got a repeated root. So x, that's going to go through at 0. This is minus 1. And it's a repeated root, which means it's going to bounce off at that point. And then minus 2 for this one. So it's a positive because every x is positive. So it's going to go W shape. But it's going to go down, then on the way up it's going to bounce off and then go up like that. So that's what happens when you've got a repeated root. It bounces off the axis. Let's move on. So this one, similar, but it's not, they haven't factorise that, so you just factorise that yourself to x plus. Oh, it does that. That doesn't factorise, I don't think. Let's just check. So 1, 5, 14. Yeah, so if it ever comes up with this, it's got an I there, that's not real, so that doesn't factorise. So what that means is it's going to cross at minus 5, it's going to cross at 4, and that one is not going to cross. So it's only going to cross the axis twice. And the other part of the W is going to be somewhere else. So 4 minus 5, and it's going to go through the axis, the y-axis at 5 times 4 times 14. So what's that? 20 times 14, 280. Sometimes I do this. 5 times minus 4 times 14, negative 280. So let's put it down here. Don't worry about your scales being the same as each other. So we're looking for a W shape. So it's going to go down, and it's going to go up. And we don't know exactly where the other one is going to be. It could go down and then W and then up, or it could go down and then W and then up. We don't actually know. And I don't think you could be expected to find that out, because that's a much more in-depth question. So let's just go down, up, and then it could just have a W here, you see, or there could be a W before. It just has to have another turning point at some point. I'm interested in what that looks like, but I'm just going to move on. The main point is that it doesn't cross the axis again. use a separate diagram to sketch each pair of graphs. So these are reciprocal graphs, so we're looking for this kind of shape. The only real difference between 2 over x and 4 over x is that 2 over x is, so when you do say 2 divided by 1, you're going to get 2. And when you do 4 divided by 1, you're going to get 4. So it's just the scale is different, but the shape is the same. If we wanted to compare, and let's just put that in the screen, if we wanted to compare them, I would probably just, if I were you, put in some different values of x to see what happens. So let's start with 1, might as well. So if I put in 1 here, just as an idea, that would be, let's call this one y equals 2 over x. The other one is going to be higher up, because 4 divided by 1 is 4. If I were to put in 2, then this one is going to be 1. 4 divided by 2 is 2. There. And so I assume at all points it's going to be twice as high. So that top one is y equals 4 over x. And then same thing on here. Not a great picture, but one of them is closer to the axis. Essentially, you can think of this one as being that one, but twice as far away from the axis, because it's 2 lots of 2 over x. So at every point, you should be twice as far away from the axis. You can always fall back on that GCSE trick of putting in different values of x, seeing what happens to y, and then just plot those or sketch those, put them about in the right places and draw a line through them. On the same axis, sketch those graphs, so a cubic and so these questions, the second part is going to be why there are only a certain number of solutions. So that goes back to chapter 3 when we're talking about simultaneous equations on graphs. Solutions to simultaneous equations on a graph is the points of intersection. So here, essentially what the question is your lines should only intersect twice. So first things first, I'll put on where the 3, we'll have 3 there, where the cubic, so this is cubic x squared and another x, is going to cross the axes, so it's 0 and 3, it's x squared, so it's going to bounce off at 0. And then, so let's just draw that. Oh, missed it. And then for the 2 over x, well, that's going to be, well, 3 would be 2 over 3, but it doesn't matter because I haven't got any scale on that. If there is a scale, you should make sure that they're about right. So this is the cubic, y equals 2 over x. This is the that's the reciprocal. This is the cubic, y equals x squared, x minus 3. And explain how the sketch shows that there are only 2 real solutions to x cubed, x minus 3 equals 2. That's what happens if you put x squared, x minus 3 equal to 2 over x and then multiply both sides by x. So the solutions to this are going to be the points where it intersects. And there's only 2 points where it intersects, so there's only 2 real solutions. The other questions are similar to that one. I will point this one out because this is quite a nice question that links back to chapter 2. Sketch this graph, so that's just going to be a quadratic that goes through 1. And then this line, so rearrange that, y equals half x minus a half. So minus a half is here, half x. It's going to have a gradient, it's going to go through 2. Is it 2? No, 1. you're going to have a graph that goes like that. So no real solutions to the equation when you put those two things equal to each other. When I say put them equal to each other, you have to make this equal to y first. So I had to put that equal to x squared plus 1, double everything, move it onto the same side, and you'll end up with this. Work out the range of values of a, such as the graph x squared plus a. So this currently is x squared plus 1, but x squared plus a and 2y equals x minus 1, so that's this equation, have 2 points of intersection. So this comes back to the discriminant. This having 2 points of intersection means that the discriminant is positive. Okay, and to make intersections we have to solve these simultaneously. Now the easy way to do that would be to make them both equal to y. So x squared plus a is already in y, and then the other one, y equals a half x minus a half, and then solve those simultaneously. So x squared plus a equals a half x minus a half. I don't like fractions, so I'm just going to double everything. What did I just do? 2x squared plus 2a equals x minus 1. Put everything on the same side. Minus x plus 1 plus 2a equals 0. This, even though it's got 4 terms, these are both constants, so they count as your c. Minus 1 is the b, and a is 2. So you can still treat it like a quadratic, because 1 plus 2a, just because you don't know what a is, doesn't mean it's not a constant. So it just combines with the c. So b squared minus 4ac is going to be greater than 0. b is minus 1, so that's 1. Minus 4, lots of a, lots of c. So 1 minus 8, 1 plus 2a, 1 minus 8 minus 16a, 1 minus 8 is minus 7, so 16a is 7, and then when we're dividing by a negative, you have to flip the sign. So those are the values of a, such that the graph will have 2 points of intersection. Now if you just go back and look at the graph, that's slightly less, or like closer to 0 than negative a half. Now I actually put a half, but that should have been negative a half. So what it's saying is, if it were to, instead of going through at 1, it goes through just above that point, then that's the point at which it's going to touch. Anything less, so it says less than negative 7 over 16, so anything just slightly below that, it's going to cross it at 2 points. So when a is negative 7 over 16, that would be tangent. Anything below that is going to cross at 2 points. And that's nothing to do with differentiation. I know you've done differentiation, and you know that there's all this stuff about like using, I could do this by differentiating the top graph and then putting it equal to a half or something and work out the x coordinates. Not that would still work, but it's much simpler. That it can all be done just with just the discriminant, b squared minus 4ac. Not to say that other questions might not use differentiation, but this one doesn't need to. Maybe that question should have been not in the basic section, but because it involves some quite tricky stuff. But now moving on to the intermediate questions. These are going to have a mixture. So this top one is quite easy. It's just a quadratic. So it can go through at 1 and minus 2. And it's going to go through the x-axis, sorry, the y-axis at minus 2. I know that because it's just minus 1 times 2. And we could work out the minimum point as well, if we need to. I'm going to do it, why not? So I find the minimum point by putting in the halfway point, so minus a half, into the original equation. So, sorry, hang on a second. Let's find the minimum point. You could just do it by expanding it and putting it in, or negative a half minus 1 times negative a half plus 2, so 1.5. So that's going to be my, just there, that's minus 2 1/4. So minus a half minus 9 over 4. Oops. Okay, so that's the graph of the quadratic. On separate diagrams, sketch the graphs of y equals f of x plus 2. So x plus 2 in the brackets means it's going to move left 2. So the minus 2 is going to go to minus 4, the 1 is going to go to minus 1, and then the turning point, sorry, is going to go from minus a half to minus 2 1/2. So you would just put that here. I'm going to have to change my scale slightly, so that's minus 4, minus 1, and then that's going to go to minus 5 over 2, minus 9 over 4. Notice that the y coordinate doesn't change because it's only at x plus 2. Nothing's happened outside of the brackets, it's all inside the brackets. If you wanted to change, you wanted to find this, you could. If it goes x plus 2, then this is going to become x plus 2 minus 1, so that's x plus 1, and this is going to be x plus 4, so that's going to be 1 times 4, which is 4. I think that's going to be the next part, so I'll explain that in a moment. This one, f of x plus 2, everything's going to move up 2. So we're using these equations to find the coordinates of the points where your graphs cross the y-axis. No, I've already done that. But, oh, that's the next question. F of x plus 2. It just says sketch it. So, minus 2 is going to move up to 0. So it's going to cross through the origin. And then that point is going to be negative a quarter. So minus a half, that doesn't change. But minus a quarter, that goes up from minus 2 1/4 to minus a quarter. The points where it crosses, or used to cross the x-axis, these minus 2 and 1, they would just be up somewhere. So that would be 1 and 2, and this would be minus 2, 2. So it's just gone up 2 from 0. To find this point, this is a symmetrical thing. So if that's at 0 and that's minus a half, that means that's minus 1. Where it crosses the axis, I already know, I've already worked it out, but I will point out one thing that people seem to not quite get. So if f of x is x minus 1, x plus 2, if I want f of x plus 2, all I have to do is change every x in the equation to x plus 2. So x plus 2 minus 1, x plus 2 plus 2. Okay, then you simplify that and you get x plus 1, x plus 4, and that's your new equation. All you do is replace the x with x plus 2 everywhere that it exists. Okay, and then you can see when you do that, you get like x plus 1, x plus 4, which is just more help to understand that these are minus 1 and minus 4. Okay, it's all coherent, consistent, whatever the word is. The other questions are similar. When it gets to finding the equation f of x plus 1, just everywhere that it says x squared, put x plus 1. And here as well, you're going to put x plus 1. So it's going to be 1 minus x plus 1. If you need to put it in brackets, do that. And this part C, f of x plus 1 is going to be x plus 1 squared, 1 minus x plus 1. So I've replaced x with x plus 1. So 1 minus 1 is 0, and then this is minus x, so I need to put a minus out front. Okay. I'm just going to quickly look through some of these other ones, see if there's anything that's different. This is actually a very good point to make. Sometimes it talks about a coordinate. So sometimes there's a picture with a coordinate on it. Sometimes, like in this case, it just says that there's a coordinate. To state the coordinates, you see there's only one mark. It's because there's not much to do. If it says f of x minus 2, that's inside the brackets, so you do the opposite. You add 2 to the x. So p would become 6 minus 1. Don't change the y because it happens inside the brackets. For this one, it says plus 3. So the 4 is going to stay the same, but we're going to add 3 to the y. And that's it. Sometimes I think people overthink those. You just have to apply the rules of translations and transformations. If it's inside the bracket, do the opposite to x, and if it's outside the bracket, do what it says to y. Sketching these graphs, what you're going to need to do is factorise that first. So for that, y is going to be x brackets x squared minus 5x plus 6. Then factorise that, so x, what's this, minus 2, minus 3. Okay, so you just put the points at 0, 2 and 3. It's cubic, it's positive, so that shape. This throws a lot of people, but if you notice what's the difference between this and this, every x has been replaced with x minus 2. So all this graph is f of x minus 2. So this graph translated to the right by 2. Okay, so move everything to the 2 to the right. So you're going to have 2, 4 and 5. Draw the same graph. And that's it. Similar things with the next few, and then it moves on to the exam questions. So you'll notice exam questions tend to have multiple questions, multiple steps. So one will be one type of question. That's actually from chapter 1. It's just factorising a quadratic. It's just like the one we just did. So that becomes x squared plus 10x plus 25. And then that's a perfect square, so x brackets x plus 5 squared. You just factorise out the x and then factorise the quadratic. Sketching the curve is going to go through at 0 and then minus 5 it's going to bounce off. So I'm going to draw it really small, but then go through at 0 and at minus 5 it's going to bounce off. It's cubic. And then showing the coordinates of the points, I've done that already, sorry. The point with coordinates minus 3, 0 lies on the curve with equation this. Now recognise that this is simply that, but every x has become x plus a. So we're talking about f of x plus a, where this is f of x. So that means it's been moved left a spaces. Okay, the point with coordinates minus 3, 0 lies on the curve. So currently I've got my points are minus 5, 0 and 0, 0. So in order for it to go through minus 3, either this has to have gone left 3 or this has to have gone right 2. Okay, in order to something to be translated to there, where a is a constant. Find the two possible values of a. So it's going to be going that way 3. That's left 3, so a could be 3, or it could have gone right 2, in which case a is minus 2. So that's 3 marks, and that's an old exam question, and it's all based on the knowledge and understanding of firstly recognising that this is just this. That's a typo there. That should say x squared. It's recognising that those two things are similar, and the only difference is you've added a to the x. And then knowing that transformations in this form means it's just moving left and right. So in order for it to go through -3, you either just have to move it left or right, left 3 or right 2, in order for a point to go through -3. There are a bunch of other questions, all of a similar kind, but this is already getting quite long, and you have got the mark scheme. So if you need any help, look at that. If you need any more help, then you can talk to each other or talk to me. Okay, thank you very much, and that's it.